June 24, 1941. Somewhere behind British lines in the western desert. Steel was supposed to stop bullets. That was the entire point of armor. But when Allied mechanics test-fired standard rifles at a captured German armored car, they watched in disbelief as rounds punched clean through its sides. 8 millimeters of steel, sloped at aggressive angles and praised by German propaganda as impenetrable protection, was failing against armor-piercing rifle ammunition. The Sd.Kfz 222, Germany's standard light reconnaissance vehicle, had a vulnerability that shocked every Allied soldier who encountered it. On the surface, the vehicle looked formidable. Angular armor plates gave it a sharp, diamond-shaped silhouette. Its open-topped turret mounted a 20mm autocannon, and with a top speed of 80 km/h, it could appear and vanish across the desert before most enemies could react. German crews trusted these machines. They believed the armor would keep them alive. What they didn't know was that British infantrymen armed with Lee Enfield rifles and armor-piercing rounds could kill them from over 150 meters away. The story of the Sd.Kfz 222 begins not with its flaws, but with the circumstances that gave birth to it. After the Treaty of Versailles, Germany faced severe restrictions on military development. Tank production was explicitly forbidden. But armored cars occupied a gray area in the treaty's wording. The Reichswehr, and later the Wehrmacht, exploited this loophole. If they couldn't build tanks, they would build armored cars to perform reconnaissance and security duties instead. Development continued through the mid-1930s as German planners refined their requirements. They needed a vehicle that could scout ahead of advancing columns, gather intelligence, survive brief encounters with enemy infantry, and retreat quickly if heavier opposition appeared. Speed and mobility took precedence over protection. German doctrine assumed reconnaissance units would keep their distance, observing and reporting rather than engaging in direct combat. The Sd.Kfz 222 emerged from these ideas. Built on a modified Horch 801 chassis, with both four-wheel drive and four-wheel steering, it represented advanced engineering for its time. The steering system allowed impressively tight turns, useful for maneuvering through narrow European streets or reversing quickly under fire. However, drivers were warned in training manuals to use the four-wheel steering only at speeds under 20 km/h. As the system became unstable at higher speeds, visually, the vehicle looked cutting-edge. When production began in 1937, the sharply angled armor plates weren't just aesthetic. They were designed to make thin armor more effective through sloping and deflection. German engineers knew that angled armor could cause bullets to ricochet instead of penetrate. The 10-sided open turret, covered by wire mesh screens meant to deflect grenades, gave good visibility for the commander and gunner while keeping the overall weight low. Its armament evolved throughout the war. Early models carried a 20mm Kar-30 autocannon paired with a 7.92mm machine gun. The first versions used the MG-13 before switching to the superior MG-34 in 1938, which became standard. In 1942, the autocannon was upgraded to the faster-firing K-38, improving performance against light armor and low-flying aircraft. The three-man crew worked in cramped conditions. The driver sat in the front hull, peering through a small armored visor, while the commander and gunner shared the tiny turret, barely larger than the interior of a modern compact car. Despite the tight quarters, crews appreciated the vehicle's mechanical reliability. The Horch V8 engine, available in 3.5-liter and 3.8-liter variants, provided sufficient power. The early 3.5-liter engine produced about 75 horsepower. The later 3.8-liter engine boosted this to 90. The real problem lay in the armor. Early production models in 1938 featured just 8 mm of rolled, homogeneous armor on every surface, including the front. To put that in perspective, 8 mm is roughly the thickness of 4 stacked credit cards. It was enough to stop pistol rounds, submachine gun fire, and distant shrapnel, but little else. Against armor-piercing rifle ammunition fired at close range, it was hopeless. German engineers understood the risk and made gradual improvements. By 1939, mid-production vehicles had 14.5 mm of frontal armor, giving them a fighting chance against rifle fire from the front. Though the sides remained thin, later versions introduced in 1942 featured 30 mm of frontal armor, a major improvement. But by then, thousands of early lightly armored vehicles were already in service, and even the upgraded models retained weak side armor. The bottom and rear decks were just 5 mm thick, enough only to deflect fragments. German planners had made a calculated trade-off: speed and mobility over protection. They assumed reconnaissance crews would avoid close contact with the enemy. That assumption would prove dangerously optimistic once World War II's brutal realities set in. German propaganda proudly showcased the 222's design. Posters and training films claimed its sloped armor would deflect incoming fire. Soldiers were told they were safe, and they believed it. The psychological effect was crucial. Confidence kept crews aggressive and willing to push forward into the unknown. The sharp-angled hull and turret mesh made the vehicle look sophisticated, almost futuristic. German troops trusted their machines because they had been trained to. Reality, however, told a harsher story. In Poland in September 1939, the Sd.Kfz 222 performed well. Polish forces, ill-equipped and unprepared, struggled to counter the fast-moving German reconnaissance units. The 222's speed and light firepower were decisive. Polish anti-tank rifles were rare, and few infantry had armor-piercing ammunition. The vehicles raced through enemy lines, gathering intelligence and spreading confusion. These early victories seemed to prove the design's worth. France, in May 1940, brought similar results. Though French forces had heavier tanks and artillery, they were outmaneuvered by German combined arms tactics. The 222 excelled in the rapid advances, screening for panzer divisions and exploiting breakthroughs. French infantry, disorganized and retreating, posed little threat to the swift reconnaissance vehicles. The 6-week campaign ended in triumph, reinforcing German faith in their equipment. The Balkan Campaign of April 1941 repeated the pattern. Yugoslav and Greek forces, relying on outdated weapons, could not effectively oppose modern German armor. The rough, mountainous terrain favored the 222's speed and mobility over heavier vehicles. Against weaker opponents, it seemed nearly perfect. By spring 1941, German reconnaissance crews had fought in 3 successful campaigns. They had no reason to question their protection until Africa. When the Africa Corps arrived in Libya in February 1941, it carried with it the same light vehicles that had served so well in Europe. The Corps, officially formed on January 11th that year to rescue Italy's failing campaign, was placed under the command of Erwin Rommel, the celebrated Desert Fox. By February 11th, the first German units of the 5th Light Division had landed at Tripoli, including reconnaissance detachments equipped with Sd.Kfz. 222s, the eyes and ears of Rommel's advancing army. The reconnaissance battalion of Clarence Abteilung 3 was among the first units to arrive in Africa on February 14, 1941, at Tripoli. This unit, equipped with Sd.Kfz 222 armored cars, among other vehicles, immediately began deploying into the desert to probe British positions and gather intelligence on enemy dispositions. The 5th Light Division would later be redesignated as the 21st Panzer Division on August 15, 1941. ATAD, transformation reflecting the growing scope and intensity of German operations in the theater. The desert presented unique challenges unlike anything German forces had encountered in Europe. Vast open spaces stretched for hundreds of kilometers with virtually no cover or concealment. Temperatures soared above 50 degrees C during the day and plummeted near freezing at night. The abrasive sand infiltrated every mechanism, wearing down moving parts and clogging filters. Supply lines stretched back hundreds of kilometers across territory with no infrastructure, making fuel and water delivery a constant challenge. For reconnaissance vehicles like the Sd.Kfz, the desert offered both advantages and disadvantages. The open terrain allowed the vehicle's speed to be fully exploited. Visibility extended for kilometers, enabling reconnaissance crews to spot enemy forces at great distances. The firm sand and gravel surfaces in many areas provided good traction for the four-wheel drive system. However, the lack of cover meant that once spotted, the vehicles had nowhere to hide. The vast distances required more fuel than the limited tank capacity could provide, forcing reconnaissance patrols to carefully calculate range and establish refueling points. The Tu-22 initially performed well in these early months of the Africa Corps deployment. British forces caught off guard by the speed and aggressiveness of German operations found themselves repeatedly outmaneuvered. German reconnaissance units pushed deep into British rear areas, gathering intelligence on supply dumps, headquarters locations, and troop movements. The speed of the Sd.Kfz proved invaluable for these hit-and-run reconnaissance missions. Crews could approach suspicious locations at high speed, observe from a distance, and retreat before British forces could organize effective responses. The reconnaissance battalion attached to the 21st Panzer Division operated continuously throughout 1941 and 1942, conducting missions that ranged from simple route reconnaissance to aggressive raids on British installations. Photographic documentation from fall 1941 shows reconnaissance units attached to the 21st Panzer Division in Libya using Sd.Kfz 2222s extensively. These images capture the vehicles in their element racing across the desert, their distinctive angular profiles silhouetted against the horizon. British forces had been fighting in the desert since Italy entered the war in June 1940. They had developed tactics and gained experience that German forces initially lacked. More critically, British forces were well equipped with modern weapons, including rifles with armor-piercing ammunition. The Western Desert was about to become a brutal testing ground for German equipment, and the Sd.Kfz 222 would be found wanting. British forces began capturing German vehicles almost immediately. The fluid nature of desert warfare with rapid advances and retreats across vast territories meant that damaged or fuel-depleted vehicles were frequently abandoned. The first major haul came during Operation Crusader in November 1941. The operation launched on November 18th with the goal of relieving the besieged garrison at Tobruk. Confused, tank battles erupted around Sidi Razi as British, and German forces clashed in swirling engagements across the desert. On November 27th, British forces successfully relieved Tobruk. By mid-December, Rommel had withdrawn to Ala. In the aftermath of these battles, dozens of German vehicles lay scattered across the battlefield. Some had been knocked out by anti-tank fire, others had run out of fuel, their limited range proving insufficient for desert distances. Still, others had been abandoned when their units retreated. British recovery teams systematically collected everything they could find. Among the prizes were several Sd.Kfz 22222s in various states of damage. Standard procedure dictated that capture enemy equipment be shipped to the School of Tank Technology at Chessy in Surrey for detailed evaluation. This facility located on Chobham Lane in rural Surrey served as the primary British center for analyzing captured Axis vehicles throughout World War II. The school was part of the Military College of Science and would later become the Fighting Vehicles Proving Establishment. Joint teams from the Royal Tank Regiment and RAM conducted detailed technical analysis of every captured vehicle, producing comprehensive reports on capabilities, vulnerabilities, and tactical implications. However, field commanders needed immediate answers. They could not wait months for reports from England. What weapons could defeat these German vehicles? What were their weaknesses? How should British infantry and anti-tank units engage them? Mechanics and engineers attached to the Eighth Army began informal field testing behind the lines, pulling captured vehicles to safe areas to examine them in detail. This pattern of immediate field testing, followed by comprehensive evaluation back in Britain, became standard procedure throughout the war. The most famous example was Tiger 131, the German heavy tank captured in Tunisia in April 1943 during operations near Dahar. Chardi Sadan in Hunter van Tawetin, also known as Jebel Jaffa. This Tiger had been immobilized by a British 6-pounder anti-tank gun hit that jammed its turret. The crew abandoned the vehicle, which was subsequently recovered by British forces. Tiger 131 was initially examined in Tunisia by British engineers eager to understand German heavy tank technology. The vehicle was then shipped to England, where it underwent months of detailed testing at Chizé. The comprehensive analysis covered armor composition and thickness, weapons systems, engine performance, transmission characteristics, and every other technical aspect. The intelligence gathered from this single captured vehicle significantly influenced British anti-tank doctrine and vehicle development. The Sd.Kfz 222s captured in 1941 and subsequently underwent similar processes, though obviously these light reconnaissance vehicles generated less strategic interest than heavy tanks. Nevertheless, the methodical British approach to captured equipment analysis meant that even relatively minor vehicles received thorough technical evaluation. Multiple Sd.K 222s were shipped back to Britain over the course of the war, with each vehicle contributing to the growing body of intelligence on German reconnaissance equipment. The first surprise was the mechanical quality. The Horch 58 engine was beautifully engineered with clean castings and precise machining. The four-wheel drive system functioned smoothly even after combat damage and desert conditions. The steering mechanism demonstrated clever design, allowing all four wheels to turn for tight maneuvering. German attention to detail was evident throughout the vehicle, from the quality of welds to the precision of assembled components. These were well-manufactured machines from a sophisticated industrial base. Then the mechanics examined the armor. Using calipers, they measured the thickness carefully and systematically. 8 mm on the sides, 5 m on the bottom and rear deck, even accounting for the slope, which added some effective thickness by increasing the distance projectiles had to travel through the steel. These measurements shocked the British engineers. One sergeant, a former auto body worker from Birmingham before the war, remarked that he had worked with civilian cars that had thicker body panels. The informal testing began almost casually. Someone suggested they shoot at the vehicle to determine what could penetrate the armor. They started with pistols, 9mm rounds from Webley. Revolvers bounced off at all but point-blank range. The armor was performing as designed against pistol ammunition. Next came the Sten submachine gun. The 9mm rounds from the Sten also mostly bounced off, though a few perpendicular hits at very close range managed to severely dimple the armor and cause spoiling on the inside surface. Against pistols and submachine guns, the armor worked. Then someone retrieved a Lee Enfield rifle. The standard British infantry rifle, chambered in .303 British, was never designed as an anti-armor weapon. It was simply a rifle intended for engaging infantry, targets at ranges up to 600 mm. The standard Mark 7 ball ammunition featured a 174-grain bullet at approximately 2,240 FD. This was typical performance for full-power rifle cartridges of Thera, comparable to the German 7.92mm Mauser or the American .306 Springfield. However, British forces also possessed armor-piercing ammunition for the .303 British cartridge. The W Mark I armor-piercing round featured a 93-grain-hardened steel core and achieved approximately 2,500 fprt per 2,235 PERS. This ammunition was specifically designed to penetrate light armor and had been developed for exactly this purpose. The proof standard for armor-piercing ammunition required that at least 60% of bullets must penetrate 80 mm of armor plate at 175 yards. The mechanics loaded several W Mark I armor-piercing rounds. One of them, who had been a competitive shooter before the war, took aim at the side of the vehicle from approximately 50 yards. He selected a flat section of the hull where the armor was perpendicular to his line of sight, rather than one of the angled sections. He aimed carefully and fired. The armor-piercing round punched clean through. The entry hole was neat and round on the outside face. The exit hole on the interior was jagged and larger, with metal fragments peeled back from the impact. The mechanics gathered around to examine the result, running their fingers over the holes. They fired several more rounds at different angles and distances. At ranges under 100 yards with perpendicular hits, the W Mark I armor-piercing ammunition consistently penetrated the 8 mm side armor. At longer ranges or with oblique impacts, penetration became less consistent. But under typical combat conditions, a British infantryman with armor-piercing ammunition could defeat the armor. The implications spread quickly through the Eighth Army. Intelligence officers compiled reports. Tank crews were informed. Infantry units received updated tactical guidance. The supposedly armored German reconnaissance vehicle could be engaged effectively by infantry with appropriate ammunition. British soldiers no longer needed to wait for anti-tank guns or request tank support when encountering Sd.Kfz 222s. Sd.Kfz 222s. A rifleman with armor-piercing rounds could disable the vehicle and kill its crew. Further testing explored additional weapons. The boy's anti-tank rifle, a 55 caliber weapon firing 13.9 mm by 90 mm ammunition, achieved 23.2 mm armor penetration at 100 wide. This was massive overkill against the 222, but it confirmed that British anti-tank rifles would devastate the vehicle. The 2P-pounder anti-tank gun, a 40 mm weapon that served as the main British anti-tank gun through most of the desert campaign, could penetrate the 222's armor at any practical engagement range. Tank crews were informed that even their coaxial 7.92 mm machine guns could penetrate the armor at close range if they concentrated fire on one spot. The knowledge spread beyond British forces. Commonwealth units from Australia, New Zealand, South Africa, and India received similar intelligence briefings. Free French forces learned about the vulnerability. As the war progressed and Allied forces expanded, the information proliferated. The Sd.Kfz 222's thin armor became common knowledge among Allied infantry, fundamentally changing how they approached encounters with these vehicles. Soviet forces conducted their own independent discoveries. On August 23, 1941, the Red Army exhibited a captured German Sd.Kfz 221 scout car, the smaller predecessor to the 2I-22, near Moscow. On September 7th, one captured Sd.Kfz 222 was transferred to the Gaz factory at Gorky for detailed examination. Gaz chief designer Vitalia Groshev and other engineers inspected the vehicle thoroughly, measuring dimensions, testing materials, and evaluating design features. Groshev was particularly impressed by the highly faceted armor plate angled for maximum ricochet effect. Although Soviet engineers had already begun work on their own light armored car design on July 17, 1941, the examination of the German vehicle influenced the final design. The BA-64 light armored car, which entered production in April 1942, incorporated a hull loosely modeled after that of the German vehicle. The multifaceted angled armor plate arrangement was directly adopted from the German design. However, Soviet engineers learned from German mistakes. The BA-64 featured 9 mm of armor on the sides, slightly thicker than the German vehicle, though still vulnerable to armor-piercing rifle fire. More importantly, Soviet designers understood that light armored cars were fundamentally vulnerable to modern anti-tank weapons and designed the vehicle accordingly, accepting limitations while maximizing production efficiency. The BA-64 was considerably smaller than the Sd.Kfz 222, with a two-man crew instead of three. It was lighter, weighing only 2.4 tons compared to the German vehicle's 4.8 tons. It was cheaper to manufacture using automotive components from existing Soviet truck and car production. Most significantly, it was easier to produce in large numbers. The Gaz factory at Gorky could manufacture BA-64s on the same assembly lines that produced Gaz-64 Jeeps, sharing components and tooling to accelerate production. Soviet production philosophy differed fundamentally from German approaches. Rather than producing limited numbers of sophisticated vehicles with complex features like four-wheel steering, Soviet factories produced vast quantities of simpler vehicles that were adequate for their roles. Approximately 9,110 BA-64 variants were built between 1942 and 1946. This included 320 original BA-64 models from 1942 to 1943 and 5.29. Improved BA-64B models from 1943 to 1946. This production total dwarfed the fewer than 1,000 SDK's 222s manufactured over 6 years. The BA-64 remained in Soviet service until the early to mid-1950s, long after the SDK 222 had been retired from German service. The Soviet vehicle was exported to numerous Allied nations including Poland, Czechoslovakia, China, North Korea, and Yugoslavia. Seeing combat in multiple post-war conflicts, its longevity and widespread distribution stood in stark contrast to the limited production and early obsolescence of its German inspiration. British forces developed their own light armored cars, including the Daimler armored car and the Humber armored car. Both featured significantly better armor protection than the Sd.Kfz 222. The Daimler, entering service in 1941, featured 16 mm of armor on the hull sides and 30 mm on the front. This provided genuine protection against rifle fire, including armor-piercing ammunition at typical combat ranges. The Daimler mounted a 2-pounder anti-tank gun, making it far more lethal against enemy armor than the 20 mm autocannon of the German vehicle. The contrast between these comparable vehicles highlights how different nations approach the armored car design challenge. Germany prioritized speed and agility, accepting minimal armor protection. Britain prioritized firepower and adequate protection, accepting somewhat reduced mobility. The Soviet Union prioritized mass production and economy, accepting limitations in both protection and sophistication. Combat experience suggested the British approach was most successful for armored cars expected to operate in contested areas, while the Soviet approach excelled at providing adequate numbers of vehicles to units that desperately needed them. American forces entering the Desert War in late 1942 conducted their own testing of captured German vehicles. American ordnance teams arrived with scientific methodology, conducting systematic ballistics tests and compiling detailed technical reports. They tested American weapons against German armor to provide tactical intelligence to troops who would soon face these vehicles in combat. The M1903 Springfield rifle, the standard American bolt-action rifle from World War I, that remained in service alongside the newer M1 Garand, fired the 3006 Springfield cartridge. The M2 armor-piercing round for this cartridge, identified by its black bullet tip, was specifically designed to defeat light armor. Official specifications required minimum 10.67 6C7 of armor penetration at 100 YD. Field testing documented penetration up to 12.7 mm at 100 yards, significantly exceeding the 8 mm armor thickness of the Sd.Kfz 222. The newer M1 Garand firing the same 3006 Springfield cartridge but in a semi-automatic rifle offered identical armor-piercing performance with the advantage of faster follow-up shots. American infantry could engage German armored cars with confidence using M2 armor-piercing ammunition. The reports noted that German armored cars could be effectively engaged by infantry with standardist Sioux rifles loaded with armor-piercing rounds, valuable intelligence for troops encountering them for the first time in Tunisia. American testing also evaluated submachine guns and carbines. The Thompson submachine gun, firing the relatively low-houred 45 ACP pistol cartridge, could not penetrate the armor except at point-blank range with multiple hits to the same spot. The M1 carbine, firing the intermediate .30 caliber carbine cartridge, had marginal penetration capability. At close range under 50 yards, it could sometimes penetrate the thinnest rear armor, but not reliably. These tests confirmed that the 8mm armor provided adequate protection against lighter weapons, just not against full-power rifle cartridges loaded with armor-piercing ammunition. The distinction between standard ball ammunition and armor-piercing ammunition was critical. Standard rifle ammunition with lead cores could not reliably penetrate 8mm of steel armor at practical combat ranges. The armor performed as designed against such ammunition. However, armor-piercing ammunition with hardened steel cores was specifically developed to defeat light armor. British, American, and Soviet forces all possessed and issued armor-piercing rifle ammunition to infantry units, particularly in units expected to encounter armored vehicles. The distribution of armor-piercing ammunition varied by unit and situation. Not every soldier carried armor-piercing rounds as standard issue. However, it was common practice to issue limited quantities of armor-piercing ammunition to infantry units operating in areas where they Keepley A2 might encounter light armored vehicles. Squad leaders, designated marksmen, and anti-tank teams routinely carried armor-piercing ammunition. When intelligence indicated German reconnaissance units were operating nearby, additional armor-piercing rounds would be distributed. Impact angle played a crucial role in penetration effectiveness. The Sd.Kfz 222's angular armor design maximized obliquity, increasing the effective thickness and encouraging ricochets. A bullet striking at a 60° angle from perpendicular had to travel through significantly more steel than the nominal 8mm thickness. This is why German engineers designed the vehicle with angled plates at extreme angles. Even armor-piercing ammunition might glance off rather than penetrate. However, in practical combat conditions, armored cars frequently presented perpendicular or near-perpendicular surfaces to enemy fire. The sides of the vehicle, where the 8mm armor was flattest, were vulnerable whenever the vehicle moved parallel to enemy positions or turned to engage targets. The flat rear deck and rear plates were even more vulnerable. German crews learned to avoid situations where their sides or rear were exposed to enemy infantry. But in fluid combat, such exposure was often unavoidable. By late 1942, the vulnerability of the Sd.K.222 was well documented across multiple armies and theaters. German reconnaissance units operating in the desert, in Russia, in Italy, and eventually in France, all faced enemies who understood that rifle fire with armor-piercing ammunition could defeat the vehicle. The writing was on the wall for the 222 in frontline reconnaissance roles. The vehicle that had performed well in Poland, France, and the Balkans, where good roads, weaker opposition, and shorter campaigns had masked its vulnerabilities, was increasingly obsolete against well-equipped Allied and Soviet forces. The thin armor, perfectly adequate in 1938 against the military technology of that era, had become a fatal liability by 1943. Armor-piercing ammunition became standard issue across Allied armies. German military leadership recognized the problem of inadequate reconnaissance vehicle protection by early 1942. Combat reports from Africa and Russia consistently highlighted the vulnerability of the Sd.Kfz 222 series Tonami fire. Unit commanders requested better protected vehicles. Crew reports detailed incidents where vehicles were lost to rifle fire or light weapons that should not have been capable of defeating armor. The response was the development of the Sd.Kfz 234 series, known as the Puma. This 8W-wheeled armored car represented what German reconnaissance doctrine should have specified from the beginning. The vehicle featured 30 mm off-frontal armor and 14.5 mm on the sides and rear, finally providing genuine protection against rifle fire, including armor-piercing ammunition. The sloped armor design maximized effectiveness, and the overall protection could resist most infantry weapons and many light anti-tank weapons. The Puma mounted a 50mm quick 39L60 gun, the same weapon used on later variants of the Panzer III medium tank. This gave German reconnaissance units genuine anti-tank capability for the first time. The 8W-wheeled configuration provided excellent cross-country mobility, with the vehicle capable of 85 km/h on roads and maintaining reasonable speed across rough terrain. The crew of 4 operated in significantly better conditions than the cramped 3-man crew of the Sd.Kfz 222. However, this capable vehicle arrived too late to make a significant impact on German fortunes. Development and production delays meant the first Pumas did not reach frontline units until late 1943. By that point, Germany was fighting desperately on multiple fronts, with its industrial capacity stretched beyond breaking. Only slightly more than 100 Pumas had been built by the end of 1943. Production continued through 1944, reaching approximately 400 total vehicles before the production line shut down in September 1944 as Allied bombing and raw material shortages crippled German industry. 400 vehicles could not possibly replace the hundreds of Sd.Kfz 222s still in service across multiple theaters. Nor could they meet the reconnaissance needs of dozens of German divisions. The Puma, despite being an excellent design that finally balanced protection with mobility and firepower, appeared in too few numbers too late to change anything. Meanwhile, less capable but more numerous vehicles like the Sd.Kfz 22222 remained in frontline service because no alternatives existed. Production of the Sd.Kfz 2222 itself ended in late 1943, after approximately 990 vehicles had been manufactured between 1937 and 1943. This production total included multiple variants with evolving specifications. The earliest vehicles from 1937 and 1938 represented the baseline design with 8mm armor throughout, and the 3.5L engine producing 75 horsepower. The mid-production upgrade in 1939 brought 14.5 mm of frontal armor while retaining the 8 mm side armor. This modification reflected growing awareness that the vehicle needed better protection, at least from the front, where it would most commonly face enemy fire during approach or withdrawal. However, cost and weight considerations prevented upgrading the side armor, leaving the fundamental vulnerability intact. The AB variant introduced in 1942 represented the most significant upgrade. The 30mm frontal armor finally provided genuine protection against rifle fire from the front arc. The more powerful 3.8 engine delivering 90 horsepower compensated for the additional weight. The faster-firing Quark 38 autocannon replaced the earlier Quark 30, offering improved performance against aircraft and light armored targets. These improvements came too late for most vehicles already in service, and even the AUBB retained the vulnerable 8mm side armor that could be defeated by armor-piercing rifle fire. Related variants in the 22 series included the Sd.Kfz 221, a smaller 3-man vehicle with similar armor issues, and the Sd.Kfz 2223, which was the radio-equipped command variant featuring additional radio equipment, but the same vulnerable armor. The Sd.Kfz 260 and 261 were further specialized command variants. All shared the fundamental weakness of inadequate sidearm protection. Many 222s were progressively relegated to rear area security duties, convoy escort, anti-partisan operations, and training roles where the opposition was less likely to possess heavy weapons or adequate supplies of armor-piercing ammunition. In these secondary roles, the vehicle's speed, reliability, and firepower remained assets. The 20mm autocannon was lethal against unarmored vehicles and effective force-suppressing infantry against partisans armed with bolt-action rifles and limited ammunition. The 8mm armor might still provide adequate protection. Some vehicles survived until the end of the war in May 1945, though by that point they were thoroughly obsolete for frontline service. The rapid advance of Allied armies in the West and Soviet forces in the East in 1944 and 1945 overwhelmed German defensive capabilities. Reconnaissance vehicles, regardless of type, had limited impact on the final outcome. The war was being decided by tanks, artillery, aircraft, and the overwhelming industrial production of the Allied powers. What made the Sd.Kfz particularly significant from a historical perspective was not its combat effectiveness, but what it revealed about military design compromises and the evolution of battlefield technology. The vehicle excelled at nearly everything except the one thing that mattered most for crew survival. It was fast, reaching 80 km/h on good roads and maintaining respectable speed even on rough terrain. It was mechanically reliable when properly maintained, with the HCH engine proving durable under demanding conditions. The vehicle offered excellent visibility for its crew, critical for reconnaissance work. The commander had good sight lines from the open-topped turret, though this also meant vulnerability to overhead threats like grenades and artillery airbursts. The handling characteristics were praised by German crews, with the four-wheel steering allowing tight maneuvers and quick repositioning. The acceleration was brisk, allowing rapid exits from dangerous situations. The armament was effective for its intended role. The 20mm autocannon, whether the Cork 30 or the later Cork K38 variant, could shred unarmored vehicles and was dangerous even to light tanks at close range. The rate of fire allowed sustained suppression of enemy positions. The coaxial machine gun was excellent for engaging infantry and could be used independently of the main gun. Ammunition stowage, while limited by the small vehicle size, was adequate for typical reconnaissance missions. If the vehicle had been equipped with just 12 or 15 mm of armor on the sides instead of 8, it would have been significantly more survivable against rifle fire while remaining light enough to retain its mobility advantages. The additional weight would have been manageable. The performance impact would have been modest, but this armor upgrade would have placed the vehicle in a different weight class, requiring a more powerful engine, stronger suspension, and ultimately driving up costs and complexity. This highlights the fundamental tension in armored vehicle design. Every kilogram of armor adds cost, reduces mobility, increases fuel consumption, requires a stronger engine, and creates maintenance challenges. Designers must balance protection against all other requirements. Sometimes the balance works. Sometimes, as with the Sd.Kfz's 222, the balance fails and soldiers pay the price with their lives. The calculated risk that German planners made in the mid-1930s did not pay off. They bet that speed and mobility would compensate for limited protection. They assumed reconnaissance vehicles would operate at standoff distances, observing rather than fighting. They underestimated how often their light armored cars would find themselves taking fire from rifles at close range. The fluid, chaotic nature of World War II combat, especially in the vast spaces of Russia and the open terrain of the desert, meant that theoretical doctrine about reconnaissance, units staying at safe distances, rarely matched reality. British intelligence assessments, compiled in 1943 for distribution to Commonwealth forces, methodically detailed every weakness of the vehicle. The documents specified armor thickness at various points, identified optimal aim points for different weapons, and provided tactical recommendations for engagement. Tank crews were informed they could penetrate the vehicle with coaxial machine guns at close range. Anti-tank gun crews were told not to waste scarce armor-piercing ammunition on armored cars when high explosive rounds would suffice and were more available. Infantry received particularly detailed guidance. Their reports reminded soldiers that their rifles, so often dismissed as inadequate against armor, could be lethal against the German reconnaissance vehicles when loaded with armor-piercing ammunition. Recommended engagement ranges, optimal impact angles, and the importance of concentrated fire were all specified. British training incorporated this intelligence, ensuring that soldiers understood they were not helpless against German armor and possessed effective means of defense. The vulnerability extended beyond armor thickness alone. The open-topped turret, while providing excellent visibility, left the crew exposed to overhead threats. Hand grenades, mortar rounds, and artillery airbursts could kill or wound crew members even without penetrating the hull. The wire mesh screen over the turret opening provided some protection against directly lobbed grenades, but could not stop fragments from nearby explosions. The cramped interior meant that any penetration was likely to cause casualties. With 3 crew members packed into a space barely larger than a modern compact car, a single armor-piercing round entering the crew compartment could wound or kill multiple people. Spoiling where metal fragments broke off the inside surface of armor upon impact, even without full penetration, created deadly projectiles that ricocheted around the confined space. The limited ammunition stowage and fuel capacity created additional vulnerabilities. The vehicle could only carry limited quantities of 20mm autocannon rounds and machine gun ammunition. Once expended in a prolonged firefight, the vehicle was defensively armed only with crew's small arms. The fuel tanks, while protected by the thin armor, could be ignited by incendiary ammunition or tracer rounds that penetrated the hull. The tires, though puncture-resistant by the standards of the era, remained vulnerable to gunfire. A vehicle immobilized by damaged tires became a stationary target, negating its primary survival characteristic of speed and mobility. Crews disabled by tire damage had to abandon their vehicle or attempt repairs under fire, neither option being attractive when facing enemy infantry with armor-piercing ammunition. German crews, to their considerable credit, continued performing reconnaissance missions with whatever vehicles they were assigned, including the vulnerable Sd.Kfz 222s. Many demonstrated extraordinary bravery, knowing or suspecting their armor was inadequate, but carrying out orders regardless. Reconnaissance is inherently dangerous work, requiring soldiers to probe enemy positions, gather intelligence, and often sacrifice themselves to provide commanders with information needed for larger operations. The Sd.Kfz 222 served throughout the war in multiple theaters despite its known vulnerabilities because Germany simply did not have sufficient replacement vehicles to retire the entire fleet. Production priorities focused on tanks, assault guns, and other combat vehicles deemed more critical to defensive operations. Reconnaissance vehicles, while important, received lower priority as German industry struggled to replace catastrophic equipment losses on the Eastern Front and to counter Allied strategic bombing. Several examples of the Sd.K 222 survive in museums. Today, preserved as historical artifacts representing German military technology of the late 1930s and early 1940s. The Wheeled Foundation maintains an actual Sd.Kfz 222 OSU, a specimen. The Boyington Tank Museum, the Australian War Memorial, and various other institutions possess examples captured during the war. The vehicle at the American Heritage Museum was captured during the Desert Campaign in 1943 and shipped to England for evaluation at Chelsea. Modern visitors examining these preserved vehicles can see the thin armor plates for themselves, understanding instantly why Allied soldiers found them vulnerable. once they began engaging them with armor-piercing ammunition, running hands over the 8mm side plates. Visitors gained visceral comprehension of just how minimal the protection actually was. The angular contours and sharply sloped armor that looked so formidable in propaganda photographs revealed surprisingly thin metal when examined up close. The Sd.Kfz 222 stands as a cautionary lesson in armored vehicle design, illustrating what happens when engineers misjudge the balance between protection and mobility. It demonstrates how machines built for the early stages of war can quickly become obsolete as weapon technology advances and enemies adapt their tactics. It shows how design choices made at the drafting table during peacetime can carry deadly consequences years later. When those vehicles are tested under the brutal realities of combat their creators never envisioned. The story also underscores the value of battlefield intelligence and cooperation among Allied forces. The rapid spread of information about the vehicle's vulnerabilities across British, Commonwealth, Soviet, and American armies ensured that Allied infantry everywhere understood they possessed effective means to counter it. This shared knowledge prevented needless losses and bolstered soldiers' confidence when facing German reconnaissance units. From a broader perspective, the Sd.Kfz 222 epitomizes the technological and industrial struggle that defined World War II. Every combatant nation wrestled with competing demands for protection, mobility, firepower, reliability, and cost. Every vehicle design represented compromises, strength in some areas balanced by weaknesses in others. The 222's particular compromises worked well in the early campaigns, but faltered as the war intensified and opponents evolved. Its story continues to resonate in modern armored vehicle design. Today's light armored and infantry fighting vehicles confront the same challenge, balancing survivability with mobility and affordability. Modern materials such as composite, armor, and ceramic plating offer superior protection at far lower weight than the rolled steel of the 1940s, yet the same fundamental trade-offs persist. Every kilogram added for safety still reduces speed and increases fuel consumption. The Sd.Kfz 222 also serves as a stark reminder of the human cost of flawed engineering assumptions. Behind every piece of pierced armor was a crewman who trusted his vehicle to keep him alive. German soldiers entered battle believing their nation's engineers and commanders had equipped them properly. Discovering that faith misplaced, that their armor could be breached by a simple rifle round, must have been a horrifying realization. When British mechanics in the desert discovered that armor-piercing rifle fire could punch through the German armored car's sides, they had uncovered one of the Wehrmacht's lesser-known weaknesses. It was not a revelation that would change the course of the war. The 222 was, after all, a reconnaissance vehicle, not a tank. But for the soldiers confronting it, the knowledge was empowering. It meant their rifles were not useless. It meant they could fight back. The 8mm of steel that German designers believed sufficient for protection proved scarcely better than thin sheet metal against armor-piercing rounds. That armor, validated in tests and approved through military channels, failed under the chaotic pressures of real combat, where bullets came from unexpected directions and at unforgiving distances. German crews paid the price for that miscalculation with their lives. As word spread among Allied troops, the once dreaded Sd.Kfz 222, renowned for its speed and agility, was soon regarded as just another vulnerable target. No longer invincible, not even particularly formidable, it became a symbol of misplaced confidence. The war had stripped away illusion, revealing that beneath the sleek angular exterior lay only fragile steel, and the sobering truth that the Emperor indeed had no clothes. No clothes.